All right, in this section, what we're going to do is we're going to take what we did last time, which was absolute values, and what we did the previous lesson, which was inequalities, and we're going to combine them. So let's see what this means, because we know that with absolute value, we have to look at both the positive and the negative. So I want all of these answers for this absolute value of x, I want them all to be greater than or equal to 2. So I know that these answers are going to revolve around both 2 and negative 2. So let's think about what values of x that if I put inside of here, would I get things that are greater than 2. So if I put, say, a 3 in there for x, that would work, wouldn't it? I could put it 2.5. I could really put anything on this side of 2, and that would work. I could even include the 2 because it says it can be greater than or equal to, so the 2 would also work. So I have all of these things would work on this right-hand side. Now let's look at the left-hand side. If I put in the number 0, 0 is not going to be greater than 2, so that wouldn't work. Let's put in a negative 3. If I put in a negative 3, the absolute value of negative 3 is 3, so that would work. Basically, anything on this side of negative 2 would work, because when I take the absolute value, it will then be greater than 2, including the endpoint. So this would be my answer to this problem. I would need to look at both the positive and the negative case, and let's see what makes sense with this. Looking at this inequality here, I could have looked at it as x is greater than or equal to 2, or I could have said that x was less than or equal to negative 2, because when I consider the negative case, I flip the inequality. So just like in the inequalities that we did before, if we multiply or divide by a negative number, we flip the inequality. So that's kind of what this is like doing. It's looking at that negative case, which changes the direction of my inequality. So I could break this one apart by looking at both the positive case, which I would look at the straight inequality, and then I could look at the negative case, which would then flip that inequality when I look at the negative case. Solving this just like normal, add 3, I would see that x can be less than 10, and then x must be, let's see, add 3, and that is x is less than, oh, I didn't flip it. Goes to show you how easy it is to make that mistake. I said it, but I didn't do it. I was supposed to flip that inequality, wasn't I? All right, so then I have a negative 4. Let's put these numbers on here, 10 and negative 4. So these values that are less than 10 and greater than negative 4 would work for this, not including those endpoints. And I always like to check an easy number just to make sure that what I shaded actually works. So let's check, there's a 0 in here. Let's see if 0 works. 0 minus 3 is that negative 3. Take the absolute value, that is a 3. Is 3 less than 7? Yes. So let me put my answer in interval notation. I didn't do that for the other one, so let's do that. I'll do it in a different color because it gets a little messy with all that stuff up here. Reading this one just straight down off the graph, I would have negative infinity, comma, negative 2, square guy parentheses, or 2, comma, infinity. That's the interval notation for that one. The interval notation for this one is negative 4, comma, 10, rounding out parentheses. All right, before I look at this, I want to get that absolute value symbol all by himself, just like I did before. So I want to look at this one as 2a minus 6 is greater than or equal to, and I'm going to add 1, keep the same inequality symbol because I didn't play with the negative there, didn't multiply or divide. Now I can break this absolute value apart by looking at both the positive case, in which case I keep that same inequality symbol, And then I'm going to also look at the negative case. 2a minus 6 is less than or equal to negative 3. Whoops. I need to scoot that over, don't I? Because you can't see it anymore. Hold on. Okay, I'll fix that here in just a minute. All right, so I'm going to add 6, and then I'll have 2a is greater than or equal to 9. A is greater than or equal to 9 halves, dividing both sides by 2. Here I'm going to add 6, I'll have 2a. I'm not multiplying or dividing by a negative, so I'm going to have just plain old 3 there. Divide both sides by 2, and I'll have a is less than or equal to 3 halves. Let's see how that fits on my number line. We'll do another color here. So let's write them in order. Here's 3 halves. Here is 9 halves, because 3 halves is less than 9 halves. And I should go less than for the 3 halves and greater than for the 9 halves, just following those arrows. And looks like I have squarey guy parentheses because it includes those endpoints, square or closed ball, whichever it is they're making you do on your XYZ. And the interval notation for this would look like negative infinity up to 3 halves, squarey guy, or 9 halves to infinity. Let's just make sure our interval works. I picked something in between here. Like, let's say I'm going to pick maybe a 4 is in between here, because that would be 8 over 2, so that's in between there. So let's check and make sure that this section right in here doesn't work, and then that probably followed that the other 2 sections would work. If you really want to make sure, you check all 3 sections. You'll check here, you'll check here, and you'll check here, and that's good practice, especially if you're taking a test. I'm going to test the 4. So 2 times 4, that's 8 minus 6. That is a 2. Once I take the absolute value, that's also a 2. Subtract 1. 2 minus 1 is 1, and 1 is not greater than 2. And I was looking to see that this section does not work because I did choose a 4 there, and it doesn't. So I'm pretty good. Let's test this section right here just to see, because that has my favorite number inside of there, so it's 0. So let's try and test that. I'll get this other stuff off of here. Okay, we're going to test 0. Now 0 should work because 0 is sitting right about here. So 0 should work, whereas 4 wasn't supposed to work, which it didn't. So I'll take 2 times 0, that's 0. I need the absolute value of negative 6 minus 1. So that's going to be 6 minus 1, that's a 5. Is 5 greater than 2? Yes, it is, and that section works. To be thorough, you'd probably want to check a number over here. Just make sure that works. I'm not going to do that right now. All right, I put another couple of them up here with fractions just because those are ones we usually have trouble with. So let's look at these. I have absolute value. Means I'm going to break it apart into 2 separate cases. I have 2x minus 5 over 3 is greater than or equal to 1/6, or I'm going to look at 2x minus 5 over 3. Flip this inequality. It's easy to forget. And then I'm going to solve both of these and see what I have, put it on the number line, and then do my interval notation. Looks like I'm going to consider multiplying both sides here by 6 over 1. That way I can get rid of these denominators. And I'll multiply this guy by 6 over 1 and this guy. And what I'm going to end up with is the 3 goes into the 6 2 times, so I will have 2 times 2x minus 5. I didn't deal with a negative, so I keep that the same. And then 1/6 times 6 is a 1, and this is a happy place for me. I can just multiply on out, and then I'm going to add 10 and divide by 4. I'm going to have 4x greater than or equal to 10 and 1 are 11. divide by 4, x is greater than or equal to 11 over 4. Going over on this side, doing the same thing, multiplying by the 6 again. I'll still have 2 times 2x minus 5 like I did before. It's just this time I'll have a negative. Oops. I'll have a negative 1 instead of a positive 1. Not a big deal. I'm happy with that. So then I'll have 4x minus 10 is less than or equal to negative 1. In this case, I'm going to add 10 to both sides, and then I'll get myself a 9. I'm going to divide both sides by 4. I'll get x less than or equal to 9 over 4. Then I need to look at my number line, be sure and put these in order. 9 over 4, 11 over 4, oops, just make it one dash there, 11 over 4. Going to be greater than that guy, including, so I get myself a square bracket. And then, excuse me, less than, square guy bracket, writing it in interval notation. I'll do that in another color. It's going to be negative infinity all the way up to 9 over 4, square guy bracket, unit width, 11 over 4, comma, ta-da. All right, so let's play again another one with a fraction. We're going to look at a positive case, we're going to look at a negative case, be sure to flip my inequality. So I got negative 4x minus 1/3 less than or equal to 1 over 6. And then I'll have negative 4x. Oops, I'm probably not going to have enough room. I'll move this just a little bit. There we go. Minus 1/3 greater than or equal to negative 1/6. I'm still going to multiply everything through by a 6. That way I get rid of my denominators. And I will end up with negative 24x minus 6 times 1/3 is 2, less than or equal to 6 times 1/6 is 1. See how pretty that is? So much nicer. I'm going to add 2, That would be a 3. Divide both sides. Watch this guy. He's getting a little tricky on me. I'm going to divide by a negative 24. And what happens when I multiply or divide both sides by a negative? You guessed it. Let's flip that bad boy. And minus 1 over 8. Cool. All right, let's go on to this next guy. I'm going to multiply by 6. Same exact thing as this one. It's just I'll get a negative 1 on that side. So I'm going to write negative 24x minus 2. And then is less than or equal to, greater than. Got to copy down the right sign. Negative 1, because I'm copying it down from there. I multiplied both sides by a positive 6, so I'm good there. Minus 24x greater than or equal to, add 2, that would be a 1. Dividing both sides by a negative 24. And that means I have to flip this inequality. So much stuff to keep up with. Now, when you go to take your test, I'll tell you what, you really should be sure and check your answers because it is so easy to make a mistake, isn't it? So, negative 1 over 24, negative 1 over 8. Yuck, these are really ugly ones. This one does this. This one goes here. And then I need square guy brackets. And there's my graph notation. And there you're just going to have you practice more and more and more of these. Fun, fun, fun. If you have any trouble, if you get stuck on something, don't keep beating your head against the wall. Be sure and send me an email, and I will try to help you work through it. Thank y'all and have a great day.